We'll discuss about this problem. In this problem, you have to calculate the change in current through this branch when the resistance R is changed from 2 ohm to 6 ohms. That means change of resistance of this branch is equals to 6 minus 2, that means 4 ohms. So what will be the change in current through this branch when the change in resistance is 4 ohms? So how to calculate this change in current? By using compensation theorem, we can easily calculate this change in current due to change of resistance. So first of all, we should know what is the compensation theorem. Here we draw two network. This simple network contain two resistance and one voltage source. So from this network we can say I is given by V divided by R1 plus R2. Now this resistance is increased by amount del R. Then the resistance current through this network is I dash. So I dash must be equals to V divided by R1 plus R2 plus del R. So due to change of this resistance R2 by amount del R, the change in current del I is equals to I minus I dash. So you have to calculate this current by using compensation theorem. So what is the compensation theorem? Compensation theorem states that in a linear bilateral time invariant network, if the resistance of any branch of a network is changed by amount del R, then the current through all the branch of this network will change, and the amount of change in current through any branch can be calculated by replacing a voltage source Vc such that Vc equals to I into del R in series with resistance R plus del R. So if I replace this network using compensation theorem, so it will be like that. This is resistance R1 is same. Now this resistance R2 is replaced by R2 plus del R with series with a voltage source Vc such that I into del R. So here is I is this I. So here is voltage source is Vc equals to I into del R, and this voltage source must be short circuited. So this is short circuited. So according to compensation theorem, the change in current, so this is del I. So change in current through any branch of a network can be calculated, can be found out by replacing a voltage source Vc equals to I into del R with series a resistance by R plus del R. Okay, and what is the I? I is the current of the when the resistance is not changed. So this current, okay, when the resistance is not changed, at this condition this is the current. And to calculate this change in current, the voltage source must be short circuited. This is the equivalent circuit to calculate the change in current by using compensation theorem. So from this network we can say that change in current is equals to Vc divided by R1 plus R2 plus del R. That means I into del R, I into del R divided by R1 plus R2 plus del R. This is the compensation theorem. So using this compensation theorem, we can calculate this change in current through this branch when the resistance R is changed from 2 ohm to 6 ohms. So now I will solve this problem using this compensation theorem. So for this case you have to calculate the current, first current when the resistance is 2 ohm. So you have to first calculate this I. So suppose this current is suppose I dash. So to calculate this I dash, you have to know the equivalent resistance from this point, source point. So this is R equivalent, suppose. Okay, so what is the current I1? I1 can be calculated as 2 volt, that is V divided by R equivalent. So R equivalent can be calculated, this is 2 volt divided by these two resistance are in series. That means it will be 2 plus 2 parallel 4. Equivalent resistance from this source point, these two resistance are parallel to each other, and with these 2 ohms these are in series. So 2 plus 2 parallel 4. So it will be 2 plus multiplication by summation, that means 8 divided by 6. Upper front will be multiplication and this is summation. So it will be 2 divided by 6, 20. Okay, so it will be 2 into 6 by 20, that means 10. So it will be 3, 5. So 3 by 5 ampere. Okay, so I dash is 3 by 5 ampere. Now we have to calculate I. What is the I? I can be calculated by using current division rule. This is 2 branch, and this current I have already calculated that this is 3 by 5 ampere. This is 3 by 5 ampere. Now you have to calculate the current through this 2 ampere. So by using current division rule, we can calculate this I. So I is given by 4 divided by 2 plus 4 into I dash. Okay, so it will be 4 divided by 6 into, this is 3 by 5, so this is 2, so this is 2, so it will be 2 by 5 ampere. So I is 2 by 5 ampere. So this current is 2 by 5 ampere. Now you have to apply compensation theorem. So how to apply this compensation theorem to this network? Compensation theorem states that the voltage source must be short circuited. So this is voltage source, this is short circuited. Okay, the resistance 2 ohm are in same, so this 2 ohm resistance is equals to 2, and this 4 ohm resistance must be as the same, so this is 4 ohm resistance. Now this resistance will be 6 ohm because del R equals to 4 and the R plus del R is equals to 6, because this is 2 and change of current is 4, so it is 6. So this resistance is 6 ohm, and with this 6 ohm the voltage source Vc is equals to I into del R, I into del R. This is the equivalent network by using compensation theorem. So what is the Vc, amount of Vc? So Vc is given by I into del R. So I is 2 by 5, so 2 by 5 multiplied by change in current is equals to 4, change in voltage resistance is 4, so it will be 8 by 5 volt. So it is 8 by 5 volt, 8 by 5 volt. This is plus minus. Okay, this is 8 by 5 volt. Now this circuit can be redrawn as these two resistance 2 ohms and 6 ohm are in parallel. This point are in same, so this circuit can be redrawn as, suppose this is Vc, this is Vc, so this is Vc, Vc is 8 by 5 volt, and now this resistance is 6 ohm, 6 ohm. Now these two resistance are in parallel, so it can be redrawn as this is 4 ohms suppose, and this is 2 ohms, this is 2 ohms. So this is the change in current, this is del I, this is del I. Now we can redraw this circuit as this is voltage source 8 by 5 volt. Now these two resistance are in parallel, so these two resistance are equivalent to this equivalent resistance is 2 multiplied by 4 divided by 6, so it will be 8 by 6, that means 4 by 3, so it is 4 by 3 ohms, and this is 6 ohms. So current is del I. So del I is given by, this is 8 by 5 volt divided by 6 plus del 6 plus 4 by 3, 6 by 4 by 3. So it will be 8 by 5 divided by, this is 3, so 22, this is 22. So from this we can write that 3 by 22, so it will be 4 11, so it is 12 by 55 ampere. Okay, so change in current through this resistance is 12 by 55 ampere. So in this way we can calculate the change in current through any branch of a network when the resistance R is changed by del R. Okay.